Hi everybody, this is Carlos Mejia, and this is the Ignite speech I did for my CAT 125 writing class at UC San Diego. It's a brief 5-minute speech on Schrödinger's cat, and I hope you guys enjoy it. A very popular thought experiment in quantum physics, referred to as Schrödinger's cat. Now, many of you have probably already heard of it before, but for those of you who haven't, I'll briefly explain the basic concepts and ideas of what it entailed. It was a hypothetical scenario in which a cat is placed inside of a box, and by the bizarre properties of quantum physics, the cat can be considered to be both dead and alive at the same time. Now, that may sound weird, but I'll explain the process of it in a minute. It was first devised in 1935 by Austrian physicist Erwin Schrödinger, and it is the most popular analogy used today to describe the concept of quantum superposition, or a particle's ability to have multiple properties at the same time. Now, the most interesting fact about Schrödinger's cat, however, is that Schrödinger himself meant it almost as a joke, mostly because he was trying to criticize or mock the ideas of quantum superposition, ideas he kind of considered to be ridiculous. You see, in the late 19th century, classical physics, which were mostly based on Newton's laws of motion, were considered to be the be-all, end-all explanation of how the universe worked, from the motion of a cannonball shooting across a field to the trajectory of the planets moving across space. As we enter the 20th century, however, and as scientists began to delve deeper into the microscopic universe of electrons and photons, many began to notice that these particles didn't actually obey Newton's laws at all. They would seemingly vanish in thin air, or appear in multiple places at the same time, or generate a whole bunch of energy out of nowhere. Classical physics didn't have the tools to explain any of this phenomena, so quantum physics stepped in to develop the rules for these properties. During the 1920s, physicists Niels Bohr and Werner Heisenberg came up with the Copenhagen interpretation, an attempt to explain the strange behavior of these particles. And it was this interpretation that Schrödinger had a major problem with. It stated that subatomic particles don't have definitive properties before being measured or observed, and that it was the actual process of measuring or observing them which caused them to collapse into a single characteristic from a pool of many different probabilities. Schrödinger was not a fan of this theory, and neither was in fact Albert Einstein, who at the time went on to famously say, "I like to think that the moon is still there, even if I'm not looking at it." Schrödinger took his skepticism and went with it a little bit further. He argued that if the Copenhagen interpretation were correct, then a radioactive substance, like uranium, could be both in a state of decay and non-decay at the same time, but that surely such a strange occurrence should have noticeable effects on larger systems, like a cat. That's where his thought experiment comes in. Let's pretend we have a cat, some uranium, a Geiger counter which detects radioactivity, a hammer, and a vial of hydrocyanic acid, a poison that could kill a cat instantly. We put all of our ingredients together inside of a steel box, hooking up the Geiger counter to the hammer. Now, if the uranium decays, the counter will detect it, releasing the hammer, which will then smash the vial of poison, killing the cat instantly. If the uranium doesn't decay, however, then the contraption shouldn't go off and the cat should be fine. But the Copenhagen interpretation states that both things are happening at the same time. Therefore, the cat must also be in two different states, both dead and alive. We know from everyday life, however, that cats can be both dead and alive at the same time, and that if Schrödinger were to open up his box, he wouldn't come across a zombie kitty halfway here and halfway to a David Bowie concert in the afterlife. Which then begs the question, what about the Geiger counter? You see, this problem, or this scenario, suffers from two major flaws, one of them being that the Geiger counter is acting as a measuring device, taking in measurements of radioactivity within the box. Remember that the Copenhagen interpretation states that once a measurement has taken place, the subatomic particles inside of the box will have adopted a single characteristic, meaning that the cat will already be dead or alive, but won't be both at the same time. Schrödinger's peers were quick to see the flaws in his thought experiment, but the replies were never critical or negative. it instead became more of a conversation, and Schrödinger's cat gained popularity within quantum physics, opening up newer discussions about quantum superposition and other topics. It led to the discussions on the multiverse, or the power of the mind on the physical world, and the power of observance. It also led to technological advancements like the quantum computer and the quantum bit, because of the interesting properties of quantum superposition. The boundaries and the possibilities of quantum physics are still being defined and explored, and for many people, myself included, Schrödinger's cat helped open the doors to this mysterious realm. I hope that after this speech, it has opened the doors for you guys as well. Thank you so much for listening. Have a good day.